Hello everyone. Today we are talking about trigonometric identities. First thing to note, what's an identity? An identity is an equation that is true all the time. For example, tangent equals sine over cosine always, no matter what. Sometimes you come across equations like y equals 2x plus 3. Well, that's not always true. It depends on kind of your y and your x. So an identity is true all the time, and these identities that we're going to look at today are true for any value of x or theta. Let's first start by doing a little recap of the unit circle. Here I'll draw basic unit circle, and let's put in an angle, say a random angle theta. It looks kind of like a 45-degree angle, but it's not meant to be. It's meant to be any sort of angle here. I'm going to drop in altitude to create a little right triangle like so. If you remember, to find this x value and this y value, we used x equals cosine theta, y equals sine theta. This is going to be true no matter where the theta is, whether it's in the first quadrant, second quadrant, no matter what. Let's also recall that the hypotenuse here is of length 1. So to start our discussion, we're going to use the Pythagorean theorem. This is a right triangle, so a squared plus b squared equals c squared applies. In this case, it's going to be what? X squared plus y squared equals 1 squared. That's just 1. And so if we replace x squared, or x, with cosine theta, we end up getting cosine squared theta plus sine squared theta equals 1. This, I know, looks a little new perhaps, but it's the same as writing cosine theta squared plus sine theta squared equals 1. It's the same thing, we just kind of use a different notation here. Okay, so let's write that down as our first Pythagorean identity. Pythagorean identity. Should make sense why it's called the Pythagorean identity, because it's derived from the Pythagorean theorem. So this is kind of where we start our identity work. Cosine squared theta plus sine squared theta equals 1. Again, it comes from the fact that we can create a right triangle in the unit circle, and so x squared plus y squared equals 1, cosine squared plus sine squared equals 1. From here, let's divide each term by, say, cosine squared. So we're going to divide each term by cosine squared theta. Well, if we divide cosine squared theta by cosine squared theta plus sine squared theta over cosine squared theta equals 1 over cosine squared theta, we can simplify these. Cosine squared over cosine squared is 1. Sine squared over cosine squared, well, that's tan squared. 1 over cosine squared, you should recall, is secant squared theta. And so here is our second Pythagorean identity. Again, it just came from the fact that we divided each term by cosine squared theta. So I'm going to write that down as our second Pythagorean identity. We have a third Pythagorean identity. Maybe some of you can guess where it's coming from. Let's divide, instead of cosine squared, let's divide by sine squared. So now we have cosine squared theta over sine squared theta plus sine squared theta over sine squared theta equals 1 over sine squared theta. So we again start with the original, divide each term by sine squared, and we simplify a little bit. This becomes cotangent squared theta plus 1 equals cosecant squared theta. As a reminder, 1 over cosine is equal to secant, 1 over sine is equal to cosecant. And so here we have our third Pythagorean identity that we're going to write down neatly here. Cotangent squared theta plus 1 equals cosecant squared theta. I like to remember that the c's kind of stay with each other, cotangent and cosecant. But of course, if you ever forget, start with the original and just divide by cosine squared or sine squared. There are a couple other identities that you should be familiar with. They are the reciprocal identities. Reciprocal identities. So reciprocal means we flip it over, so that means something like secant is equal to 1 over cosine. Cotangent is equal to cosine over sine, and other identities like that. The other subset is even and odd identities. We will go into more depth in a later class, in a later video perhaps, but something to keep in mind. Even-odd identities has very much to do with even-odd functions. So these are our main identities that we're going to work with today. We're going to work with this main category first, and let's go from there.